Okay. Hi, good afternoon. Everybody's awake yet, right? Yes. I watch out for you, Margaret. Margaret's in the front seat. So for all of you, that's Margaret right there. Why don't we start with a video? Some breaking news. Now, this video, I'm not very tech savvy, so anybody who is tech savvy, please see me after the presentation, because this will sound and look like a kung fu movie, because that just presents the tone of this entire class. Okay, it's a kung fu movie, but the details in the lesson is there. Okay.
Leslie Miller, live in Montebello, where crews are trying to clean up a giant mess. Leslie.
That's right, Mark. This is the Paramount Boulevard overpass, and below is the 60 freeway.
Oops.
That's where Caltrans crews will be working throughout the night to clean up all of that fuel that spilled from the tanker truck today during that fiery crash. But tonight the big question remains, how severe is the damage to the overpass and the freeway from today's inferno on the 60? 11 hours after the fiery crash, crews...
Uh-oh. It's loading. Or is it?
Crews are on the scene still cleaning up the mess. The big tanker truck carrying 8,800 gallons of gasoline burst into flames on the 60 freeway under the Paramount Boulevard overpass, sending clouds of thick black smoke into the sky and turning a busy freeway into a parking lot. The heat from the fire was so intense, officials believe it caused structural damage to both the bridge and freeway.
The flames are so hot that it causes the cement to expand and pop or crumble, so it can leave the surface of the bridge to become almost brittle.
Pieces of metal and concrete were dropping from the overpass as the fire continued to engulf the truck for almost 2 hours. 200 firefighters from LA County, Montebello, and
that truck is right there. Is me, the white truck.
Situation.
One of the things that we were trying to evaluate was, do we put more water and foam on it and create a bigger issue with the runoff?
Crews spent much of the evening offloading the remaining gasoline in the tanker and using high-pressure hoses to wash away the remnants of fuel and the heavy soot that's covering the bridge and freeway.
We had quite a bit of runoff. We did a very good job of diking and containing all the runoff to keep it out of the storm drains and out of the waterways.
The CHP says the tanker was moving when it caught fire. Both the driver and passenger managed to get out safely. The cause of the explosion is under investigation. The tanker will be inspected to see if there was any mechanical defect. The fire shut down the 60 freeway in both directions between the 710 and the 605 freeways, causing traffic chaos.
It did take us several hours. We had vehicles that were obviously stopped on the freeway that had to be turned around and diverted off at numerous on and off ramps.
Caltrans structural engineers won't even get to the scene until tomorrow morning after all of that heavy soot is washed away. At that point, they'll be able to determine whether the integrity of the bridge and the freeway have been compromised because of today's tanker fire, and they can tell at that point when both will be able to reopen. Reporting live in Montebello tonight, Leslie Miller, ABC 7 Eyewitness News.
Okay, so that was a tanker fire at the 60 freeway going eastbound, and it just so happened that the tanker fire parked right underneath the Paramount Boulevard overpass, and that's where it exploded. And you see all that, the aftermath of that. And chemistry is written all over it, and that is why you're all here for chemistry, right? Yes, who has had more than Chemistry 101? More than Chemistry 101, why are you here? I'm just kidding. Because this is basic chemistry for the non-chemists. So, and before I make fun of them, who are the lawyers here? Okay. Are you a prosecutor, ma'am, or
I guess
a freelance?
I dabble.
Oh, she dabbles. Okay. Okay, I won't make fun of lawyers because there's one here. So, anybody from CHP? Nobody. Yes. Okay. Let's start off with some definitions. Because you see, this is basic chemistry, okay? Basic chemistry. It will refresh your memory if you've had Chemistry 101 like what, 10 years ago or something. To some of you, less than that, that's what I mean. I work for Los Angeles County, and I've been with the county Los Angeles Fire Department, the Hazardous Materials Division, for 21 years. I started when I was 52. I just use a lot of moisturizer, okay? No. You see, the thing is, there's a story there, because I've been doing the Scupa conference thing for, what, 5-6 years now, and I've always said, I've worked for Los Angeles County Fire Department for 21 years, and I always say, I started when I was 12. And then there are blank faces on people like, really? He's that young? So now I'm doing it the other way. Really? He's that old? But okay, I use a moisturizer. Like you, sir. Just kidding. Okay, listen, that is, oh, it does work. Look at him. But no, what I'm saying is there is a reason why people don't sit in the front, Margaret, but you did. So, okay, suffer the consequences. Just kidding. Let's start off with some basic definitions. Again, this is basic chemistry, so let's start off with, am I too loud? Yes, for you, because you're in the front. Well, chemistry. Chemistry is the study of matter and the changes it undergoes. And you see, with the tanker fire, you see that the gasoline is undergoing a lot of changes, okay? And that's what chemistry is all about. Now, if we talk of the study of matter, what is matter? Again, this is very basic. I know some people, oh my goodness, are we going to elementary school? Yes, you are. Matter, anything that occupies space and has mass. But since we say occupies space, then we have to define volume. Volume is the space that matter occupies. And the units include cubic feet, cubic meters, liter. Mass is the quantity of matter. The units include grams, pounds, ounces. To those of you who are nuclear physicists, are there some nuclear physicists here? Dot. Nuclear physicist? No, you're not. Pounds. Pounds is actually a unit. They say it's not a unit of mass, it's a unit of weight, because it's the measure of the gravity, but this is basic chemistry. So let's just make it simple. The units of mass can be grams, pounds, or ounces, okay? Well, the density is the mass per unit volume. Why do I go way to the basics? Because as inspectors and as emergency responders, you read material safety data sheets. And this is what you read. You read the densities of material, and you have to go back to the basics when you make sure that if it floats, if it sinks in air, if it's heavier than air, and so on and so forth, right? Now, since we are talking of matter, let's talk about the properties of matter. Anybody want to venture, how many physical states of matter do we have? Sir, how many physical states? 3. He said there are 3 physical states of matter, and those are? Solid, liquid, and gas. For basic chemistry, correct. And you're saying, no, there are no 3 physical states of matter. And you are? What's your name, sir? Jose. And you are from? San Diego County. Where's Mike Vigier? Is he here? No, good. So I can make fun of him. No, I can't make fun of the chief. Come on. So you're saying it's not 3 states of matter, right? So how many are there? 4 plus? Possibly 5. Actually, as I said, the nuclear physicists are coming up with, well, what about the flame? The flame, you cannot say, the flame itself, okay? The flame itself is not solid, liquid, or gas. It's something else. But this is basic chemistry, so we return to what he said. There are 3 physical states of matter, solid, liquid, gas, okay? But those solids, liquids, and gases have properties, right? And what are their properties? There are physical properties that it describes the response of the substance to some external influence. And the examples are color, density, vapor pressure, so on. Chemical properties are the properties that describe the interaction of the substance with another. Their reactivity, radioactivity, their flash point, so on. And corrosivity, which we'll talk about the pH later. Now, as far as properties are concerned, if there's anything that you will learn from this class, and I hope you learn something, is this, the vapor pressure. Water has a vapor pressure of 18 millimeters mercury. Acetone. You know how acetone evaporates readily, right? It has a vapor pressure of 182 millimeters mercury at 20 degrees centigrade. And concentrated sulfuric acid, 65% is 1.6 millimeters mercury. Okay? That should not happen, but okay. So all you need to remember for vapor pressure, when you're reading a material safety data sheet, an MSDS, you're going to an inspection. All you need to do is to remember 2, 20, and 200. If it's closer to 200, it's closer to evaporating very readily, as far as millimeters mercury, right? Now, if it's closer to 2, it doesn't really evaporate that much. You know, it's like sulfuric acid. But as hazardous materials specialists, you have to understand that even if the vapor pressure is close to 2, sarin has a vapor pressure of 2.6. Sarin has a vapor pressure of 2.6, so does that mean I can come close to sarin? Of course not, because the toxicity is really, really high. So a very, very small concentration of sarin can actually give you some detrimental effects to your health, okay? Speaking of which, there's an introduction to toxicology class on Thursday. I just met the instructor. Don't go there. No, I'm just kidding. No. She's a doctor for NOAA. Her name is Karen, somebody. She's very nice. I will attend her class, so I'm inviting you to join me, to support her. I don't know her. Anyway, so going back to vapor pressure. It's very relative. At least you know how the material will behave. If you see, oops, what happened there? It's anticlimactic, sorry, but it happens. Okay, so I did not do anything. Is there something going on here? Is there a ghost? Okay, specific gravity is the ratio of densities. For liquids, the reference point is water, so it's just 1 gram per ml or 8.34 pounds per gallon. We will talk about the units later, okay? Because sometimes if the specific gravity is given as 1.6, that doesn't necessarily mean 1.6 pounds per gallon, you see? The units will be different. You have to multiply 8.34 to 1.6 in order to give the density in English units. And I'm going really, really fast here. If you have any questions on the basic chemistry part, please ask Margaret, okay? Because Margaret knows. She attended Chem 101. 2 years ago, right, Margaret? Yeah. Yes, you see, she uses a lot of moisturizer. Okay. Who was laughing there? Just kidding. It's going to be fun. Who am I going to pick on next, Jose? Point to somebody. I'm just kidding. He pointed to his seatmate. Okay, for gases, the reference is air. The air density is 1.21 gram per liter or 0.0075 pounds per cubic foot. Some MSDSs list the specific gravity. This is like some of the errors that MSDS writers do, because specific volume is just the opposite of specific gravity, but sometimes they list it as density when actually it is specific gravity. They put density equals 1.5. And there's no unit to it because it's a specific gravity. It's not a density. Okay? Now, chemistry is the study of matter, so we have to, I wonder if we can pause this. Does anybody know PowerPoint? Of course you do, but you won't help me, right? I'm on my own, I'm sure. Where's Carl? Carl Palladino was here in the previous class and he helped the other guy. But anyway, I hope it stays. The matter can be divided into 2, pure substances and mixtures, and then mixtures can be divided into kind of 3, heterogeneous mixtures, suspensions, solutions, and then the pure substances are elements or compounds, right? Now I usually talk about the heterogeneous mixtures and the suspensions to just get it out of the way, all right? Heterogeneous mixtures are mixtures of pure substances, actually, and if you get a part from the top and you get a part from the bottom, it's totally different. They have different concentrations, different composition. That's what heterogeneous mixtures is all about. It's not homogeneous. It's not identical. You know, the people who are standing at the back, there are plenty of seats right in front. Join Margaret so I can pick on you. No, I'm not gonna. I promise I won't pick on you. There are seats at the. There are actually seats here and there. Please. We will pause the presentation for these latecomers. I'm sorry. Those who drank coffee first before coming to our class. No, thank you. Thank you very much for coming, actually. Sorry. Okay. So heterogeneous mixtures, that is very clear. Anything that is like actually a mixture wherein there's three solids, wherein there are three states of matter in the mixture, that's a heterogeneous mixture. Because if there's a solid, if there's a liquid, and there's a gas in the water, like beach water. Beach water has solids in it. It has dissolved oxygen, which is gas, and then there's the liquid, the water itself. That's heterogeneous mixture. That's beach water for you, especially Santa Monica beach water. Ooh, that is really a mixture, right, sir? You're from what, sir? What company or?
I'm with the Environmental Training Center.
Oh, Environmental Training Center. You're home-based where?
I know as much as you do, so be careful.
Whoa! But I have the microphone. There you go. Because he said that he knows more, he knows the same, as much as I do, or maybe even more, but I have the microphone, you see. That's my, okay, suspensions. Suspensions, that's kind of a special classification of matter for me, because I know to some of you, you've heard this already before, maybe from my previous chemistry. Oh, it did. Thank you. Thank you, God. Thank you very much. From my previous chemistry courses, I always talk about my son, because my son is allergic to a lot of different things. And one of the things that he's allergic to is milk. Milk is the most basic example of a suspension. So meaning there are solids suspended in the liquid, right? There's buttermilk fat that's suspended in the solids. Now, if my son wants to eat Jell-O, and we find some Jell-O that's kind of cloudy, okay, that's kind of cloudy, then we know there's milk in it. But if it's clear, red clear, and that's red cloudy, then if it's red clear, it's a strawberry or whatever flavor, but it's not cloudy, then there's no milk in it. He can eat it. So that's why I always give it as an example, because another example is if you have an organophosphate. All of you are, most of you are inspectors, right? And you inspect. Is that ours? No, there's not ours, huh? Let's just all riot and then, okay. Anyway, my point is, organophosphates emulsify. If you drop something into water, it just emulsifies and makes it cloudy. And that is an emulsion, and that is a suspension, okay? So we're done with suspension and heterogeneous mixtures. Now we go to the elements and the compounds. The problem is, it was too anticlimactic. I had a line for this one, but I will use it anyway. This could be the scariest picture to all of you, the periodic table. But you see, it's anticlimactic. You saw it already. Only he laughed. And your name was James. James Slade. Thank you very much for laughing. I mean, even if it's anticlimactic. Thank you. Now, when there's a periodic table, we have to talk about the elements, the atomic number. Atomic number is, what is the atomic number, James? The number of atoms in that element. Is that me?
It's next door.
It is next door. Okay. Because I don't want to alarm these two gentlemen who know as much as I do. I keep an eye on you. Atomic number is actually the number of protons in the nucleus. And if the element is a free element, if it's a stable element, it must have the same number. Okay. It must have the same number. Everything is screwy every time I make a presentation, so bear with me, okay? The periodic table is, on the left-hand side are the metals, and the right-hand side are the non-metals. And the non-metals, the very end is the non-metals the noble gases on the very end have 8 electrons in their outermost shell. What is an outermost shell? That's the outermost shell is the area where electrons are active, meaning they can be shared, they can be transferred, they can be given away, and so on and so forth. So, but then the thing is, the group 8 noble gases, they are very, very stable. Okay, so all these other elements would like to be a noble gas. I mean, I would like to be as noble as he is, but is he noble? That's the question. But anyway, we will find out later, right, sir? What is your name, sir?
Will Powers.
Will Powers, really, that's a very strong name, but Comandante is stronger. Anyhow. Okay, so all these other elements have their protons and electrons, but they want to be as stable as the noble gases. So if they have 7 electrons in their outermost shell, they just want to take one from somebody else, like James would do. Right, James? You will just take one and grab one, just so you can be stable. But then sometimes Margaret, instead of taking one, she will give away all of her 7 because she's a giving person. So that's what she will do, just to make sure that the outermost shell will still have the stable number of electrons. And that's what happens with in making compounds, right? We talked about the atomic weight, atomic number. That's not very important. Does anybody need to know that? No. Okay, go. Oxidation states. The oxidation states are the charges the ions carry, okay? If they are positive, they're cations. If they're negative, they're anions, right? Now, meaning if James took 1 electron from Margaret, he will have 1 electron more than he needs to balance his state of being. Like if he has 7 electrons and 7 protons, that will, the positive versus minus the negative, it will actually just balance itself out, right? But then if he takes in another extra electron from Margaret, he will have more negative particles than the positive particles. So he will be a negative ion, and he is. He seems negative to me. And Margaret seems positive. You see, that's a trick there. Anyway, free elements, I told you, carry 0 charge, and depends on the group of the table, the vertical structure of the periodic table. If it's group 1, then it has 1 electron in the outermost shell, so on and so forth. Some may exhibit more than 2 oxidation states, meaning those transition elements in the middle, because they have so many electrons in more than 3 shells, right? So they those electrons can just jump from one shell to another. Now, the compounds are made based on the octet rule. As I said, they want to be stable. So they want to get 8 electrons because they think they will be stable because the noble gases has 8 in the outermost shell. So that's what James does. He just takes away 1 electron. The bonds may be ionic or covalent. Ionic means you just really give it away. But then sometimes Margaret and James are very friendly with each other. Are you? No, they're not. They're not. They don't even share anything. But anyway, but this time the ions, they might share together, all right? Remember, carbon is in the group 4. He has 4 protons and 4 electrons. Now, if you're in the middle of the road, like middle of the road between 8 and 0, then you don't even know if you're going to give away the 4 or am I going to take away the 4. And that's what carbon is. He doesn't know if he wants to give or just to take away from somebody. So he just shares, and that's what covalent bonds is. Compounds can be salts or non-salts. A salt is a metal plus a non-metal. Usually they are solids. Non-salt is made solely of non-metal atoms. Remember, we talked about the periodic table. Periodic table on the, what is this? The left-hand side are the non-metals, and the right-hand side are the metals. Now, if the compound is made only of atoms on the left-hand side of the periodic table, then that is a non-salt. And it could be organic or inorganic. Organic will be, we'll tackle that later because Margaret took that like 15 years ago, organic chemistry. No, not 15 years, it's 6 years ago, Margaret, right? Oops. Okay. I told you don't sit there. No, she was the very first one who came in, and then I got to talk to her, so. What is your name, sir? Dan. From San Mateo County. San Mateo County. Okay. Okay, Dan. Watch out. Oops. Where are we now? Compounds. There are rules in naming compounds. Again, what we're touching on are really basics, and then I'm going to tell you stories about my incidents. This will help you, hopefully, when you read MSDSs and when you inspect facilities with, exotic gases, exotic chemicals, and things like that. Inorganic binary salts end in "ide," such as sodium chloride. Oxysalts end in "ate." For the normal ion, permanganate or perchlorate for one more oxygen than the normal ion. ITE or "ite" is one oxygen less. Hypochlorite or chloride is the only one that I can think of, for 2 oxygen atoms less. Next, the root names of organic compounds is based on the longest carbon-to-carbon chain plus the functional groups. We will talk about the functional groups later. Organic compounds follow the sequential prefix meth, eth, prop, but, like methane, propane, so on and so forth. Now we talk about organic compounds. Organic compounds, hydrocarbons, there are 2 types, the hydrocarbons and the hydrocarbon derivatives. The hydrocarbons consist only of hydrogen and carbon, and they end with ane, ene, ine, and diene. And the main hazard is flammability. Some are highly toxic, like benzene, which is a known carcinogen. And then some of them are explosive also. Acetylene, calcium, no, not calcium carbide. But the ones with a triple bond between the carbons, when they are sharing too many electrons between each other, there are 3 bonds, then that is quite explosive. Because the most stable hydrocarbon is the ones that are saturated hydrocarbon, meaning it's saturated with all hydrogen atoms around the carbon atom. Then there are the hydrocarbon derivatives. This is just for you to familiarize yourself with the names of chemicals out there so that when you read MSDSs, you don't feel like Margaret. Oh, no, I'm sorry, like Dan. Right, Dan? Yes, he reads MSDSs. What is this ion? Oh, what is that? Anyway, so hydrocarbon derivatives, it's based on, the functional group hydroxide, the OH, those form alcohols which have wide flammable ranges. Now, alkyl halides are generally toxic, like perchloroethylene, trichloroethene, trichloroethane. As long as you have some halogen in it, it makes it toxic. Nitro makes it explosive. TNT. What is TNT? TNT, Mr. Trinitrotoluene. And you actually pronounce it correctly, sir. Power to you. No, because a lot of people in private industry, where are we now? In private industry? Back. Oh, there. Oh, man. Again, anticlimactic, but it's okay. It still works, especially for James. Anyway, what did I do? This clicker is not working with me. I'm going forward? I did that first time, but keep going. Maybe it's me, or maybe it's James. There, I'm here, right, okay. Where were we? See, I lost my train of thought. We're talking about hydrocarbons. Trinitrotoluene, when I make inspections, a lot of people in industry, actually some inspectors still, they say not toluene, it's how do they pronounce it? I don't know how to pronounce, can you pronounce toluene for me, ma'am? Oh, now I remember. They pronounce it as toluene or something. They put an L. No, there's no L there. There's toluene, right? Will Powers? All right. Now, I'm sorry, the type of solutions is based on the solute and solvent, solid and liquid, expressing concentration. This is the most important part for solutions. We talked about the elements already, and we breezed through the elements. Now we're breezing through solutions. I remember when I was, middle school or high school? I don't remember now, because I'm 73 years old. I use a lot of moisture. We talked about, when we talk about solutions, the main semester is ways of expressing concentrations. And by goodness sake, it's like, you need this. You need calculations in hazmat chemistry, because this is by far the only thing that you need for the solutions. Because you need percent concentrations by weight. You need to know about molarity. You need to know about pH. pH is the negative logarithm of the hydrogen ion concentration. Molality is not too much used, but in one of my incidents, I had an ice making company who has a salt solution, and he has to express the solution in terms of molality, because that gives him an idea of how far down 0 degrees centigrade he can go to freeze the ice, okay? And for the most part, you need to know about parts per million. And I cannot express it anymore, but parts per million is weight of contaminant per million weight parts of the mixture, or maybe volume units also, you can do it, but for the most part, it's weight of the contaminant per million weight parts of the mixture. Now, in order to understand ways of expressing concentrations of solutions, you have to go to the dimensional analysis. Dimensional analysis, you have to understand that. All these you have to be familiar with. Thanks to Apple, iPad, and so on and so forth, all these digital technology. Now we know about nano. And we know about giga. Now I know about tera, actually, because there are like, external hard drive that's on sale for $500, 1 terabyte. Is it $500? No, it's only $200. Jose, you're overpricing. No, it's only like $99 for 1 terabyte. So it's 10 to the 12th. Now for ppm combination, any combination that will lead to a difference of 6 powers of 10 is the parts per million. So if you have 7 micrograms of meth in 1 gram of mixture, that is 7 ppm. Why? Because the difference in powers of 10 is 6. There's micrograms into 1 gram of meth. Is that correct, sir? What is your name, sir?
Jed.
Jed? And you're from what county?
City of Vernon.
City of Vernon. We're practically neighbors, Jed. I'm from Los Angeles County. I should see you. And I asked him because I was in the mode for meth, and I saw him. I just saw him because he's right here. What are you implicating? Nothing. Okay. Sorry, okay? Are you a lawyer, by the way? No? Okay, good. Okay. Be familiar with the conversion factors. I'm sure you are all familiar with this. But again, remember, this is basic chemistry, okay? Estimation of vapor density is based on the ideal gas law. But the most important thing that you need to know is that the average molecular weight of air is 29. So any contaminant with a molecular weight that's greater than 29 will most likely behave as a heavy gas. And there's a very useful formula to get the parts per million if you know the gram per cubic meter concentration, or vice versa, okay? Buffer solutions. Buffer solutions is a mixture of a very weak acid and its conjugate base. For example, acetic acid and sodium acetate. When you mix it together, any acid that you add or any strong base that you add, it will not affect the pH. That's why it's called buffer solutions. Let me see. You know, like a buffer is like some sort of a shock absorber, okay? So you do know that, for example, if you have 1 gallon of pH, let's just throw it out there, maybe pH 5 of a solution, and then you add 2 drops of concentrated hydrochloric acid, the pH will go up, right up to pH 1 because it's logarithmic. Remember what do you call this? The ways of expressing concentration. pH is the negative logarithm of the moles per liter of the hydrogen ion concentration. You are nodding your head, sir. What's your name? Miguel. Miguel, you know about that, right? So Right, correct, hydronium ion. But if you put 2 drops, just 2 drops into 1 gallon of pH 5 water, it will go way up to pH 1, just 2 drops of concentrated hydrochloric acid. So in order to avoid that, you use a buffer solution, and buffer solutions are just that, to absorb the shock. A buffer solution is a weak acid and conjugate base, or the weak base and its conjugate acid, like ammonium hydroxide. Ammonium hydroxide is a weak base, then you give it ammonium chloride, and then if you put 2 drops of acid, it will not change the pH so much. The problem is, you might think that, oh, well, what if I put like a gallon of pH 5 and then you put a cup of concentrated hydrochloric acid? That doesn't work, okay? I'm just talking about drops and drops of strong acids, because of course, if you put that much strong acid, then of course the pH will go way up, all right? And now, anticlimactic again, I again prepared for this line, but what can I say? This thing is not cooperating with me. My buffer solution in life, I am so stressed actually at work, I'm stressed. Can't you tell? I just use a lot of moisturizer. But this is my buffer solution. My son and my 13-year-old daughter. Wait, you were supposed to say, "Aww," because you see the problem is it was anticlimactic. I know. But who has 13-year-old girls here? Can we talk afterwards? I really need help. Can't you tell I really need moisturizer? Because I mean, she looks fine, right? But then at home, it's another story. Okay. Now, this thing here is the video, but it doesn't work on the PowerPoint, so I have to.
No, y de aquel lado también va otra. Mira.
Ay, se le va a quemar la escalera al bombero, cabrón.
Híjole.
Mira, los chorros de agua se ven muy buenos.
Sí.
¿Dónde, mami?
Allá, donde se va a
Ya.
¿Eso ayuda?
Nunca me he visto eso.
Haber explotado un tanque de gas.
Va a llegar a las 12. Bueno, está llegando a las 9.
Oh, shit. Mira nomás, mira. Damn. My God. Mira. Damn. Híjole.
Ay, a veces no le pasó al bombero.
I got that one.
The Spanish thing that I wanted to translate was híjole. That. I know it's just an expression, right? Okay. Okay, that is the titanium fire in South Central Los Angeles, and I presented a really lengthy expose on what happened there. If you missed that, sorry. No, I can just condense everything in maybe 5 minutes after when we are discussing already the incidents. Okay, in the meantime, those things, remember the tanker fire and now this explosion, the big explosion, that's actually chemistry, okay? That's chemistry working because it's the study of matter and the changes it undergoes. And obviously an explosion and a fire, some things are going on, some changes are going on, okay? So that is actually reaction chemistry. Now let me see if I can work this thing. No, it doesn't work. Oops. Okay, types of chemical reactions. Synthesis is a direct combination. It's just A plus B equals AB. Decomposition is if you break it off, the compounds, you break it off into two different things. Single displacement substitution is A plus B, C to AC plus B. Double displacement is like a AB, and then B we go to C, and then the D will go to A. Acid-base reaction is a special kind of double displacement because you form water in the end. Oxidation reduction reactions is like remember we talked about the oxidation states, that some chemicals, some elements exhibit more than one oxidation state, and that is what's happening with an oxidation reduction reaction. The element is actually exhibiting more than one oxidation state because sometimes it's going to be in the first reaction, sulfur has, somebody help me. Sulfur has positive 2, and then over there it becomes minus 2, 5, is like 3 or something. My math is bad, but my chemistry is good, okay? Okay, combustion is a special redox reaction, okay? What can I say? I can only be good in one thing. That's what my wife kept telling me. But combustion, she laughed. Why did she laugh at that joke? You're not supposed to laugh there because it's about my wife and it's about me. Anyway, organic, combustion, which is what happens with the gasoline tanker, is a special redox reaction, okay? Oxidation reduction reaction involves a change in oxidation state. The oxidation state of free elements is 0. Some elements may exhibit more than 2 oxidation states. We talked about that. This is just a high school chemistry thing, Geroa. The oxidizing agent, which is the oxidizer, gains electrons, which is GE is for gains electrons. R is for reduced. Oxidizing agent is for OA. So that's just to give you an idea of which element is gaining electrons and which element is the one reduced. Non-metals usually act as an oxidizer, and the metals act as reducing agents. Group 1 metals react violently when oxidized. And then the activity series, this gives you an idea of which metals can release hydrogen from water or can release hydrogen from acid. Combustion, which is what we saw the very first video. We have slow versus rapid combustion. Just keep in mind that the sudden evolution of gases creates excessive pressure. Sudden evolution of gases, when there's the reaction, then it forms, that will give you a big bang, which is what we got at the titanium fire. Slow combustion takes place at low temperatures. It occurs at the molecular level. Actually, I don't have that incident anymore in the PowerPoint presentation, but I had an incident where there was a spontaneous combustion. It does happen, spontaneous combustion. Right, Jose? Yes, correct answer. It does happen. But spontaneous human combustion, does it happen? No, Jose, no, it doesn't happen. What, are you from X-Files? No, you're not. Or Twilight Zone, yeah, spontaneous combustion. Oh, how many here have gone to the Tower of Terror of California Adventure? Dot? Yes, did you like it?
Yeah, I went yesterday.
Oh, you know what? Oh, I'm sorry. We can talk later. No, you want to? I want to share because this is physics now. I was wearing my car keys like this, okay? And when it dropped down, this guy floated in front of me. And it was so cool. I mean, that's good. Try it, Tower of Terror. And it has the Twilight Zone theme of some sort. And that's only when it comes to spontaneous human combustion, Jose. So you see, Jose, you should not watch too much TV. Your mom told you that already, right? Anyway, that's slow combustion. Slow combustion is the spontaneous combustion because it happens. One of my incidents, there were no sources of ignition, and yet it happened in a trash, roll-off bin? A trash bin. Some painters, they used staining. You know staining? Who knows about paint stains, the stains? Tell me, are they flammable or not? Yes, sir. What's your name, sir? Bob. I like that name, Bob. What about me, Bob? Okay, Bob. What can you tell us about paint stains, wood stains? They're combustible, to say the least. Some of them are flammable, right? And they're combustible. Now the problem is, when they're combustible, and it's very close to something that heats up, then it will just spontaneously ignite. And that's what happened when we responded to a trash bin fire, and we did not see any source of ignition. No cigarettes, no, although of course we cannot rule it out too, but then we saw bundled up rags that are used for cleaning wood stains, and then it's bundled up, and we are in Los Angeles, we're not in, where is the coldest part of the state? Kern County? No, not Kern County. Big Bear or something. Somebody here from Big Bear? I want to go to Big Bear. Well, bless you, sir. Bless you very much. Okay. We did not see a source of ignition, but we just saw those rags, and it caught on fire. The only thing that we can think of is spontaneous combustion, wherein there is up to the molecular level, there is oxidation of the wood stain. It's being oxidized, and then heat is being evolved in a redox reaction. In a reduction-oxidation reaction, usually heat is involved. Heat is being released. So at a certain point, that heat actually reaches certain temperature, and since it is very close to combustible material, which Bob suggested, which is correct, actually, it's actually accurate. So it did catch fire, and then we had to respond, okay? Oh, by the way, any questions about this so far? No? Good, let's move on. Dot? No questions, thank you. Incomplete combustion, complete combustion, all the elements convert to carbon dioxide and the oxides, the common oxides of the elements. But if there's incomplete combustion, that is the problem, and which we will tackle when the tanker fire at Freeway 60. Combustion in air will result in nitrogen or oxides of nitrogen in the flue gas. Now let's talk about, this is the more interesting part, right? When I tell stories about the incidents that I go to, okay? We will talk about tanker fire on the 60 freeway, the aluminum powder, which is actually my favorite incident of all time, and I will tell you why. Remember, I've been with the county for 21. I did emergency response. I was responding to incidents for 11 years. So I did get quite a bit of chemical incidents. And I usually relate it to chemistry, because there's always chemistry around us, especially we're in the environmental health field. It's like, and it's a good thing that you came in numbers. That's good, thank you. Because they always say, you don't need chemistry. You don't need chemistry. No, you do. You cannot remove chemistry from hazardous materials. Does everybody agree there? You cannot remove chemistry from hazardous materials. And what I see is when I go to an incident, I see, is there chemistry involved? And actually, there's always chemistry involved. But sometimes it's just so common that it's already automatic, that you don't need to do any kind of thinking or research in your head. So we will tackle tanker fire on the 60 freeway, the aluminum powder incident, food grade chemicals. We had a recent incident on food grade chemicals. Who inspected a food grade chemical warehouse recently? Any inspectors here in San Bernardino? San Bernardino? Where are you from, Jose? San Diego. Do you have a warehouse, chemical warehouse in your inventory? You don't know. Oh, what do you do there? Are you an inspector?
Supervisor, right? We do some hazmat inspections at farms.
Oh, farms. Okay. Okay. Farms have, food grade chemicals, I think. But we'll tackle that later. You disappoint me. I'm sorry. I'm just kidding. Hey, I just kid around a lot, okay? Right, Dot? Yes, ma'am.
Grade glycerin?
Yes. Yes. Did you inspect some food grade?
We just had somebody start up a liquid cigarette company, and they had 55-gallon drum of food grade.
Glycerin. I'm sure they got it from Brentag Pacific. Somebody from Santa Fe Springs here? No. Huh. Okay. Yes, they get those drums from a warehouse which specialize in food grade chemicals. And your name, ma'am, was? Val. Come on down. No, just kidding. Val, you are from what county?
Lake County.
Lake County? Where's Lake County?
Okay, it's 2.5 hours north on 5, 2.5 hours north on 101. North in the middle, there's a big blue lake called Clear Lake.
Oh. I don't want to go there. Okay, is there good temperature, climate? Are you like in the middle of the road, or do you get really, really hot?
Very hot, and we also have some snow.
Oh, you have some snow. We should talk later. Because if there's nobody from Big Bear, I have to go to Lake County. Tahoe is like very like this.
That's Lake County.
Oh, that's Lake County too? Oh, okay. All right, we talk about food grade chemicals. We talk about the titanium fire, but a condensed version, because what I did 2 years ago for the Coupa conference is 2 hours of titanium fire, because it's really very interesting. Remember that video, the video with the big explosion? That was titanium fire. Okay, let's start off with the tanker fire. Now, recall the very first video with the gasoline tanker. And I told you what happened there was, well, after 6 months of investigation, they found out that the truck actually dropped the drive shaft. So it was a mechanical failure, okay? So it dropped the drive shaft, so it bounced about, and it sparked, and the gasoline caught fire, right? But then the passenger saw the smoke, so he asked the driver, stop. And of course the driver stopped right beneath the Paramount Boulevard overpass in Montebello. Because everybody there, so many fire departments there, and of course us, because we take care of the hazardous waste there. I mean, we enforce the hazardous waste control law. So anyway, we were saying, if only he parked 100 feet to the north, to the east or to the west of the Paramount Boulevard overpass, it would not have been as massive of a mess that it had been. So let's talk about the tanker fire. You see, so he parked right underneath the Paramount Boulevard overpass. And the Paramount Boulevard overpass is the only way to go to the Montebello Town Center, the big mall of Montebello. So, and this is December of 2011. It's the Christmas season. So everybody was like, you have to open the freeway, you have to open the Paramount Boulevard overpass. So the pressure is there for us to do a lot of expediting. You know, we have to do everything fast. If Marcus Luke is in the back, right there, I know him, he's from LA City, and I can make fun of him because he can take it. Right, Marcus? No, okay. I knew you would say that. But anyway, it sat on the Paramount Boulevard overpass, everybody was pressuring us to first to open the freeway, and then to open the overpass. And we are as the responders for hazmat, we are, I'm sorry to say, but we are looked upon by all the fire departments for some decisions too. Even if it's the fire chief you saw in the video, it's actually, I'm sorry to say, but it was I actually who was there in the meetings of in all the executive briefings from the engineer, the transportation, is it Caltrans or those Caltrans engineers who will make the decision on what to do with the Paramount overpass, okay? So everybody's challenged. First, the bridge needed to be assessed by structural engineers. Now, we need to know what the products of combustion are. What do you think are the products of combustion for gasoline? Yes, ma'am. You are from what county? Santa Clara County. Santa Clara County. I know some people from Santa Clara County. And your name is? Chelsea. Chelsea? Chelsea. What do you think is a product of combustion of gasoline? Huh?
Petroleum hydrocarbons.
Correct. Petroleum hydrocarbons. Because sometimes they break it down to carbon dioxide or other oxides of nitrogen, but sometimes it just keeps it as is. And that is the problem. Because if we only know that the smoke is just full of soot. Were you surprised that your answer was correct, Chelsea? No. Wow, she's very confident. No, you see, yeah, because there are petroleum hydrocarbons. 80% of soot is what? Pure carbon, elemental carbon, okay? Pure carbon. But soot still has some unreacted petroleum chemicals, petroleum hydrocarbons, which is what her answer was. She answered the 20%, I'm answering the 80%. So it's elemental carbon. So the bridge is covered with soot. And now the soot, we don't know if there's benzene there or if there are other petroleum hydrocarbons there. So we had to make sure. So the question was, is it hazardous waste or not? If it were just elemental carbon, would it be hazardous or not? Who's a hazardous waste inspector here? I know Jose is a supervising hazardous materials specialist, right? Somebody, come on, be brave. Who is a hazardous waste inspector? No. Okay, then I point. You, sir. If soot is just pure elemental carbon, would it be hazardous waste or not? No. It would not be hazardous waste. Can you please explain? And your name is? Jim. Jim. Sorry, but nobody raised their hand, Jim, so I have to point at you. So, Jim, elemental carbon is not hazardous waste anymore because, I'm sorry to put people on the spot because that's just me. I'm sorry. No, but then I help you anyway. I help you, okay? I help you. Because it's not characteristically hazardous or listed. Correct. It's not. It doesn't exhibit characteristic waste or any listed hazard, which is hazardous waste 101. It's very, very elementary, basic. If it does not exhibit any of the characteristic waste, or it's not listed under the FKUP list, then it's not hazardous waste. Elemental carbon. Well, it depends on the size. Actually, it depends. I mean, if it's very, 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 very small, micrometer kind of situation or nanometer situation, then maybe it's a possible hazardous waste because it might get ingrained and might cause inflammation and so on and so forth. But in order to find out, you have to attend Karen's Introduction to Toxicology class, which I intend to do. Remember in the class? Sorry, nobody's listening to me now. Okay, hey, this is the more interesting part of the lecture, okay? So those are the challenges. Now, what is the resolution? Soot is mostly carbon black, but it's in the nanometer range. It's in some of them are in the breathable range. Soot may also contain other unburnt hydrocarbons, where Chelsea's answer came in. And wastes considered, oh, you know what? You saw this slide, Chelsea, huh? That's why you know I'm just kidding. I'm just kidding. You're just smart. I know you're smart. You actually look smart, Chelsea. Unlike some people I know who uses moisturizer. I'm just kidding, Margaret. Okay, because she's at the front. Anyway, so the decision there was we have to make a decision on what to do with the soot. The engineers, the construction engineers, the person who will actually assess the bridge, they're not hazmat specialists. They're structural engineers. So they cannot be exposed. They're not HazWOPER trained. They don't know chemistry. Maybe they have chemistry 101, but that's about it. So they cannot be exposed to hazardous materials or hazardous waste. So we have to clean it up first. But the question is, if you clean it up, you need to find out if you want to collect it or not as hazardous waste or not. And we made the decision, again, my chemistry knowledge and everything, because of the fact that 20% might be unburned hydrocarbon, we have to address it as hazardous waste. So, now the next question though is, since it is in the nanometer range, the contractor, I won't name names, but it is, what is the name of the company? I forgot. Ocean Blue, sorry, but I won't name their company name. I just did, I'm sorry. So I know their intention is great. They are after public health too, but sometimes they go overboard, right? And we have to put a stop to things that they want to do, because I know it might be conflict of interest, because if they do more, then they can bill more, right? So they suggested, hey, it could be in the nanometer range. It's breathable and everything. We can put curtains on the Paramount overpass, but so that we can capture all the dust particles that's going to fly out in the air, right? But the question is, if we do that, then how much more time is it going to be to delay the entire operation? So that's why we had all these executive briefings between the transportation engineers, and we had conference calls, because this is like, I think, how many millions of dollar project it is. I'm pretty sure it's over $6 million. I'm pretty sure, but I'm not sure the exact range. But anyhow, so we talked about the nanometer range and this and that, breathable range, and then the thing is, it's going to happen at night anyway. So we said no to the curtains. No to the curtains. And so we just pressure washed and made sure that everybody is at a safe distance, so that everything that's wet, if they're wet, they're going to go down eventually anyway. They're not going to be suspended in air like the suspension that we talked about, emulsion in air. It's not going to happen there. Thank you very much, ma'am, for attending. Oh, she's coming back. I did that one time and it backfired, but anyway, that's my problem. The evaluation, please. What do you call this? So the resolution was not to bring in those plastic curtains to capture the dust particles, because we would make sure that the public is at a safe distance, right? And at the same time, we're going to do it at night when there's less chance of people getting exposed. And the tanker fire, we opened the freeway not the next day, like in 3 days. It took 3 days because they had to demolish it. They had to demolish. Eventually, we cleaned it up, right? We cleaned up the overpass, the bridge, and the transportation engineers assessed it. And of course, you know, you saw the video. I mean, you saw that how intense the heat is. I mean, how intense the fire is. So it must be compromised. The bridge must have been compromised. So they had to demolish the bridge. And so the freeway was closed for 3 days. And then the freeway was open, but then overpass was constructed during the weekends only. Of course, they had to get the funding first and so on and so forth. And it did not open until like May of the next year of previous year. So it took around 6 months to build the Paramount overpass. So that's what happened with the tanker fire. And again, there's chemistry all over it. And you see the thing is, it's nice to be part of the executive briefing when you know what you're talking about. If I did not know about what Chelsea said, if it's just elemental carbon and what Jim, is that right? And what Jim was saying that it's non-hazardous waste, then I could have said, go ahead, just spray everything on and then just let it go. Because it's not hazardous. But then because I know what Chelsea knew, that 20% could be unburnt petroleum hydrocarbons or broken down petroleum carbons. Instead of a 24 carbon chain, it became 12 carbon chain and so on and so forth, but it's still hazardous. Now let's talk about my favorite incident of all time. I don't know if you've heard about this favorite incident of mine because it's an aluminum powder incident. Again, we're talking about a nanometer range of the powder. What happened is this happened in the height, at the peak of the foreclosure, like 2008 or 2009. I was asked to respond to a foreclosed home because some teenage kid was asked by a realtor to clean up the garage of a foreclosed home. Actually, it's not a garage. It was what do you call those? Not a shed. Well, it's sort of like a tool shed, but it's bigger. Okay? And he saw this container. It's not very clear, but it says danger, explosion hazard, contains aluminum powder. But then the thing is, you see, we're in central Los Angeles, and it was in Lancaster, which was like at least 2 hours away from us. You see, Los Angeles is big. How big is Lake County? Very small. How big is your population? 2? No, 5. Oh, 62? And you're here, so only 61 are left there? No? No? 62,000, okay. Because in LA, we have more than 10 million people. And so that's why our houses are like this, next to each other. And because you know, I went to Florida, right, for Christmas. Why am I telling you this? Because I want to. Anyway, I went to Florida to visit my wife's family. I wonder why, right? They don't like me, but no, I was forced to go to Florida. And we went to a hotel where there was a view of the city, and they call it city. The view of the city, it's actually Jacksonville, right, in northern Florida. And I was it's a restaurant at the top of a building. I don't know how many stories that was, maybe 27, because that's the highest they can go. No, just kidding. I don't know. But all I saw were trees. I said, you have too many trees. I mean, where are the houses? Oh, they're all covered, or they're like an acre apart. That's how it is. In LA, in 1 acre, you can have like 100,000 people in 1 acre. Okay, so it's like they're all crammed up right there. See, so it's like a clown house or a clown mobile, right? Everybody keeps coming out, but that's the way it is. The same thing here in Los Angeles County, because of more than 10 million people. Even if it's going to take me maybe just an hour and 15 minutes to get to Lancaster because of traffic and all the congestion and all these people honking at me or something. Because I drive like an Oriental driver, okay? So don't drive behind me, nor in front of me, just stay away. Anyhow, okay. It took me like 2 hours to get there, right? So the teenage kid already called his boss. The boss called 911 because of this danger explosion hazard. So by the time I got there with my partner, actually my partner was a little delayed. I'll talk to my boss about that. But anyway, The point is, I got there, the sheriff's bomb squad was there, the sheriff's department patrol was there, sheriff's hazmat was there. All neighbors were like, what is happening, what's going on, and so on. So it's like a public assembly already, right? So when I got there, decisions have to be made, but even if I know what should be done, because of what it generated, meaning the crowd that it generated, you have to think twice, because look what happened. There's a 30-pound container of aluminum powder found in a foreclosed home, which I just said already. Container clearly marked, keep away from water. Literature on aluminum powder. Explosive dust formation possible. It's water reactive, producing hydrogen gas. And of course, hydrogen gas, you know, is also very explosive. The bomb squad was on scene with hazmat. The challenge, how to handle and dispose the aluminum powder, right? So, I researched everything and so on and so forth. So I know that it can create dust explosion, but it can also be water reactive. And the main problem there is the, oh, I should be fast, because I have 3 more incidents to discuss. I talk a lot, huh? Ma'am, I talk a lot. Sorry. Nobody needs a break, right? No. Okay, because what is the resolution? Because I looked at all the literature, you cannot put water. Water will produce hydrogen gas for this aluminum. But we all know that we have aluminum cans and it's got contact with water and so on and so forth. Oh, they have somewhere to go. Look at them. Bye. You're welcome. You're missing a lot, ma'am. Oh, but it's it's okay. You see, my evaluation will go down now. It's okay. To avoid dust formation, you need to stabilize the powder. Okay? Meaning, you cannot just transport it dry, or else it will form dust, right? And because if it forms dust, then it might have a dust explosion in your hands. To stabilize meaning to avoid the dust formation, we can use water or cooking oil. And this is actually the nice thing about the crowd there, because we were talking, right? We were talking about hazmat, bomb squad, and so on and so forth. I told them, you know, that we have to stabilize because of the dust formation and so on and so forth. And then we said, why don't we do this? We do like a bench scale situation wherein we try first a few things with the aluminum powder, and if it works, then we go all the way with the drum, right? So we said, how to stabilize it? We have to make it wet, okay? So what do we wet it with, right? So we told them, well, it says you cannot do it with water, but I have to stabilize it. I said, so maybe a most benign one is cooking oil. So we just asked the crowd, well, actually, I did not ask the crowd. It's the bomb squad person with a badge and somebody looking like you, sir. And your name is? John? You're not from bomb squad, are you? No, okay. From where?
Texas.
You're from Texas? Yeah. You're from Texas? Wow, okay. But you're here now, right? And you represent what county?
What county?
Yeah.
Whole state of California.
The whole state. Oh, you're from EPA? No. DTSC? Industry. Oh, from private industry. Okay, all right. Okay, I'm gonna pick on John now because he's not one of us. I'm just kidding, people. Okay, so all I did, oh no, not me, the bomb squad person who looks like John, but shorter. How tall are you? 5'11". You see, he laughed. The guy behind you laughed because I asked how tall you were. How funny is that? I mean, I don't know. Anyway, the guy from bomb squad, not as tall as John, asked the crowd, can somebody give us cooking oil? Whoa, and there are a lot of people just brought their cooking oil stuff. It's because they brought gallons and some bottles because they just want this to just get it over with, because the crowd is there and the fire trucks and so much nuisance to their neighborhood. So they brought out gallons of cooking oil just to check it. And you know, I just need like a cup. But it was funny because the crowd actually just cooperated to us. And maybe because it was somebody who looked like John with a badge that said, we need cooking oil. And then so they all came out and brought their cooking oil. But the other choice, though, is to leave as is. The best option, though, in hindsight, is to leave it as is. Why? Because when we came there, when we arrived, the container was already open. So that means it has already been exposed to air, and it could easily have been already oxidized. But the actual option that we used is to mix with water. I know for a fact that it would have been better to just leave it as is and just prevent it from forming dust. And how do you do that? Just by closing the container. Leave it as is, because there's no dust formation if you close the container, and there's no water reactivity because it has already been oxidized. But we mixed it with water because we did the experiment thing, the bench scale, Jose, that I talked about in the watch glass. We put, of course, we were wearing PPEs, and we took a sample. We put like a pinch on one dish and on one watch glass, and then another pinch on another watch glass. We used cooking oil on one, and we used water on the other. And then just to stabilize it, with the cooking oil, since the cooking oil was too thick, it doesn't readily mix with the aluminum powder, so we still have to agitate it and so on and so forth. So we said, oh, not a good idea, because if you want to stabilize it with some liquid, it has to readily be absorbed or be wet, okay? And so when we did it with water, there was no spark, no nothing, because it has already been oxidized. It has already been oxidized. The surfaces of the powder have already been oxidized, so we mixed it with water. And you know why we did not leave it as is? Because there was a crowd. There was a crowd forming, and then they said, and the bomb squad was saying, there is an explosion potential in your neighborhood. So we had to do something to pacify the crowd, to make sure that we are taking care of it. So we had to do something, because we cannot just leave it as is and then wait for the cleanup contractor to arrive. And by the way, the cleanup contractor arrived the next day, because it was already like 12 midnight or something like that. So you see, logistically, it was easy to do, but we had to do something. We had to mix it with water. The powder did not react with water because its micron size is not small enough, or most likely already oxidized. Now let's talk about food grade chemicals. Lake County. Okay, this one, food grade chemicals, we courtesy of Brentag Pacific Incorporated. It's a large chemical warehouse in Santa Fe Springs. Food grade chemicals is a whole different animal already, if you don't know that yet, because they have their own regulations. They are self-regulated, not because of the hazard. It's because it is going to be consumed by people, the public. And who used to be a restaurant inspector? Come on, somebody was a restaurant inspector. Yes, ma'am. Your name was? Caroline. Caroline. When it comes to food contamination, what is your main concern for food contamination? I know. What contaminant is the most common for food? Bacteria. Correct, bacteria. Oh, she's a very good inspector. No, you're not? I'll talk to your boss. I'll change his mind. That is what food grade chemical warehouses are all about. They don't concern themselves with what Jim knows about characteristic wastes. They don't concern themselves about that. They concern themselves with bacteria. So they have dedicated pipes, they have dedicated rooms, they cover everything, and they have demarcation lines, because they don't want any, and since they are food grade chemicals, some of them can be eaten by rodents and other vermin. So they have to make sure that no rodents are inside the warehouse. And they have mouse traps and everything, and they have white borders on the corners of their warehouse to check for dirt where bacteria can grow, and rodent droppings and things like that. So they're very, very careful with their chemicals not to be contaminated with bacteria stuff, which can harm us when we eat their chemicals. The problem was they did, not Brenntag Pacific. Brenntag Pacific is, of course, top of the line. I mean, they have all these administrative engineering controls and so on and so forth, just to make sure that their food grade chemicals are clean without bacteria. Some companies, though, I won't name names. This time I really won't name names because they're under litigation. Okay. You did not hear that from me. Did you hear that, ma'am? No, you didn't. Okay. Food grade chemicals are generally recognized as safe, or GRAS, and they are regulated by FDA, but basically because of what she said, what Caroline said, which was they should be free from dirt, they should be free from bacteria, and they can be eaten they can be safe for human consumption. They should be safe to come in contact with food or can be used as a food additive. Those are food grade chemicals. Food grade chemical companies have very stringent standards for cleanliness, which is what I mentioned. Because of dirt and things, bacteria can grow there, molds and things like that. They're not supposed to have that in their warehouse. And they have food industry branches. They are like, there's beverage, meat and poultry, baking, wine, seasonings. Because you see, even if they have like conveyor belts, they have to wash it with nitric acid or some other acid, but very, what's the word that I'm looking for? Chelsea, you should know that. Not highly concentrated, weak. Dilute. Thank you. Thank you. Your name was?
I didn't say anything.
Oh, you didn't say it? Who said dilute? Okay. My pal from Glendale, of course. Okay, so very dilute nitric acid because it has to be clean. So the thing is, the nitric acid that's dilute came from a concentrated stuff. You see, and that's what they keep. Some companies, not Brenntag Pacific. Please, Brenntag Pacific was very cordial, and their operation is top of the line. And I owe them these pictures, so I have to say that. Problem was, one company threw away food grade calcium oxide, and it caused a trash truck fire because of reactivity. Calcium oxide reacts with moisture. Food grade chemicals should be evaluated for their hazard characteristics before deciding on how to dispose of them. Just because they are clean and free of microbes or bacteria, or it can touch food or something like that, doesn't mean it is safe. Doesn't mean it's non-hazardous. And that's the lesson, because we responded to a trash truck fire because they threw away food grade calcium oxide to the regular trash, and they thought that since it's food grade, I mean, what harm can it do? But then other stuff got into the that is wet, other wet papers, wet clothing, clothing, and so on and so forth. And it reacted and caused trash truck fire. Next, the titanium fire. Remember the video with the big explosion? The big explosion was in South Central Los Angeles, and that was taken. That's a YouTube video, actually. There was already a smaller explosion before that big one. Okay, it happened at a metal recycling facility. And the metal recycling facility, they sort their scrap metal into different stuff, into, say, name metals. Name some scrap metal. Chelsea, name some scrap metal. Aluminum, yes, aluminum. They have, of course, stainless steel, they have carbon steel, and they have titanium. Okay, what happened here was somebody was not welding, not cutting, deburring or, huh? You know, with the smoothing, grinding. Thank you. Sorry. You see, sorry. I'm good with chemistry, but not with words. You see, I'm not. So he was doing some grinding operation, and sparks are going, right? And the sparks actually landed on a titanium pile, and it started to smolder. Titanium fire. Let's call this. When companies handling titanium should have their graphite powder fire extinguisher. Okay, it's like they call it metal X. It's a graphite powder situation wherein it should be dry, and you just smolder the fire and remove the oxygen from the reaction, right? And that's what's supposed to happen. But then it's a big pile, so they don't have that much metal X graphite powder to put on the smoldering fire. So they had to call on the fire department. They told the firefighters, no, don't put water. But they did, because they didn't have a choice at that time. So that's not mine. Because of the radiant heat, a propane tank exploded nearby. A propane tank, because of the radiant heat of the titanium fire. That explosion triggered that video guy using his phone. Because of the explosion, it triggered him to record it. So he was recording it. He really did not expect that a bigger explosion is going to come out of it, and it did, right? Because the firefighters kept drowning the titanium fire with water, and at a certain point, it just gave out, meaning the titanium fire actually released hydrogen gas, and just as soon as it was released, it just spontaneously exploded. This is what happens because titanium burns at very high temperatures. We have recorded temperatures of over 1500 degrees Fahrenheit. At that temperature, from laws of chemistry, what do you call that? The Boyle's law and the Charles law and things like that, way back in elementary. The pressure can go 5 times the atmosphere, and the steel boxes where the titanium was stored actually shattered. It's amazing that nobody died from that incident. There was only one injury, blunt injury, but he's okay now. I think he's okay now because it's been 2 years. He got a blunt injury because of the shattered steel box. Blunt injury there. Hydrogen gas is formed in 2 ways. To decompose, water needs so many calories, but then Merck index stipulates that the steam that you use to surround and drown the fire can decompose at 1300 degrees Fahrenheit. And I told you we have recorded it at 1500 degrees Fahrenheit. And it's actually not at the center of the fire. It could have been way over 1500 degrees Fahrenheit. So therefore, if water decomposes into what? Water decomposes into hydrogen and oxygen. And you told me you don't know anything about chemistry. Oh, you didn't say that. I'm sorry. She did not say that. Okay, so it can actually decompose, or it can also react with the unburned titanium to form the titanium oxide and hydrogen gas. But remember that the fire situation is uncontrolled. So actually what happened there was, aside from the big explosion, there were smaller mini explosions, because so many pictures of several seemingly like fireworks situation there. Now this one is a sad incident, but it happens. There's chemistry in committing suicide too. That was me, and somebody died because he mixed muriatic acid and hydrogen and fungicide. The IDLH is 100 ppm, but 400 to 800 ppm can cause unconsciousness. And this is the formula. Calcium polysulfide plus hydrochloric acid will form hydrogen sulfide gas plus more calcium polysulfide. So it keeps doing it and doing it and doing it, right? Wait a minute. I was also invited to a webinar, and there has been empirical studies about suicide chemistry too. Hydrogen sulfide, especially in a car, in a smaller enclosure, it can actually go all the way up to 8,000 parts per million in the breathing zone. And the average, and of course you know that IDLH is 100, and it can cause unconsciousness. What they say is, I don't know if it's true because I have not tried it, and I won't try it, because they say that it is a painless way to exit out. You become unconscious, and you keep breathing it in, and so all your systems will just give out because you keep breathing it in, because you're already unconscious, and that's what happens. The good thing for responders, though, is that the studies, who works for CalARP, California Accidental Release Prevention Program here? You're a CalARP inspector, sir? You're familiar. What is your name? Mike. Mike. Oh, from San Diego? Contra Costa. Oh, well, CalARP is, of all the counties, I mean, Contra Costa is like the epitome of CalARP because they have all the different refineries and chemical manufacturers there and everything, and explosions too, right, Mike? No, well, a few. Anyway, no, because I was talking about stability class. I was going to talk about stability class and the wind direction and wind speed and things like that, because empirical studies also showed that even if it goes up to 8,000 parts per million, once you open the door of a car or once you open the door of a bathroom, it depends on the atmospheric pressure and the wind stability and wind speed and so on and so forth. It can drastically go down so that it will be way below IDLH within 5 minutes. All you have to do is just open the door, and then in 5 minutes you can actually go back in, and the concentration is already below IDLH. Again, it depends on the time of the day, if it's a stability class, because you know when we do consequence modeling and so on and so forth, right, for CalARP, that's what we do. We plug in the stability class and wind speed and wind direction. If it is really very aggressive, then it will drastically go down. I mean, do you have any questions? That's all the incidents, but let me give you one last video. I hope this works. I hope you don't become like this. After this class, don't be like this. I like him. My kids like him too. The good thing about his comedy is that there's no dialogue. You can actually just see how fun it is. I mean, he doesn't have to say anything. And of course, there's a boy. He leaves the boy. There was an explosion, but I don't mind. I don't care. But there was a boy in there. And he's trying to put it back inside. But he escapes anyway, so that's good. That's it. Any questions? I hope chemistry doesn't scare you, because it's wonderful, okay? Hi, Margaret.